The Xunta de Galicia's Regional Ministry for the Environment, Territory and Infrastructures, through the company Augas de Galicia, commissioned Constructora San Jose to carry out the work on the subsea pipeline in San Cibrao, Cervo, as part of the 2000-2015 Galician Sanitation Plan. The site is located around the industrial estate of Coiña in San Cibrao, part of the borough of Cervo in the province of Lugo. The work will allow for the sea discharge of wastewater from the wastewater treatment plant located in San Cibrao on the coast of Lugo. The project forms part of the 2000-2015 Galician Sanitation Plan, designed to ensure compliance with current sanitation legislation. The scope of this work will cover the borough of Cervo, made up of 6 parishes with a total population of 5,046. The work consists of the construction of a pipeline which will carry water treated at the San Cibrao Wastewater Treatment Plant, WWTP, 700 meters offshore, and a diffuser that will complete the improvements to the sanitation network and the new San Cibrao Cervo Treatment Plant. The pipeline starts at the San Cibrao WWTP and is made up of an initial overland section and 2 subsea sections, a main section and a final diffuser section. The project plans specified the use of a traditional directional drilling technique using a drill guide for the 685 meters that made up the main section of the pipeline. However, at the proposal of Constructora San Jose and due to project deadlines and permits involved, the decision was taken to use an innovative full-section directional drilling technique. This technique consisted of full-section directional drilling, thereby eliminating the need for the drill guide procedure. This required a prior feasibility study in order to determine the degree of compatibility between the technology and the machinery involved and the site conditions. It was vital to ensure that drilling could be successfully carried out using this technique and to determine the optimum engineering solutions. The study therefore included geotechnical and geophysical tests, as well as terrain and the collection of topography and bathymetry data. In order to obtain the information necessary for the measuring processes, geodesic and topographic data were captured in the marine environment, bathymetry, and on land topography, using differential GPS for the bathymetry within the framework of the ED50 official Spanish datum. The use of full-section directional drilling technology offers major advantages over traditional technologies. Lower risk of drilling fluid spillage into the sea during the process. Reduction in the volume of drilling fluid at the start point. Reduced risk of drilling rig rupture. Reduction in likelihood of drilling errors. Reduced environmental impact. Once the data capture process was completed and the feasibility plan had been approved, the full-section directional drilling process was carried out for the 685 meters of 315 millimeters polyethylene pipe. The drilling gradient for the main section ranged from a height of plus 21.5 to minus 18.7 meters at the end of the diffuser section, with a 14 degrees angle of attack and a 1 degrees gradient at the end of the pipeline. Both alignments are joined by a 600-meter radius curve. Drilling work for the entire 685-meter section was completed in just 10 days. Rig 3500.9 drilling equipment was used, weighing 63 tons and with a power of 3,500 kilonewtons. Bentonite drilling fluid was used during the process. Pre-assembly of the pipeline was carried out on the dockside belonging to the aluminium manufacturing company Alcoa in San Cibrao, where the pipeline sections were welded together. Once the drilling process was completed and the pipeline sections had been welded, the entire subsea section was raised and placed in the sea. A vessel was used to tow the pipeline from the dock to the laying point. This process was carried out overnight in accordance with the terms and conditions of the license issued by the Port Authority and in order not to interrupt sea traffic. Once the pipeline reached the borehole start point, it was laid on the seabed using the pipeline filling. The pipe was tipped, enabling it to hook onto the reamer hood and was then inserted into the completed borehole. Once the pipeline was laid, the connection was completed with a concrete casing between the wastewater treatment plant and the pipeline. The final phase consisted of the construction of the pipeline terminal, consisting of a 14-meter-long diffuser pipe with 3 riser pipes. The trench was excavated using rammer hammers for the pre-excavation work and underwater blasting on the seabed. The diffuser section was also pre-assembled on the Alcoa dockside. In order to protect the diffuser section, a layer of prefabricated concrete ballasts were used and the seabed was levelled off with riprap in order to ensure the regeneration of the zone's ecosystem. Prior to the start of operations, a test was carried out using colouring to ensure that it was working correctly. The use of this technology offers major advantages over traditional methods, allowing for deadlines to be met whilst at the same time complying fully with safety standards and ensuring correct geometric positioning, as well as minimizing the impact on the environment. The technical complexity involved, the use of cutting-edge technology, and a deep concern for the environment have once again positioned Constructora San Jose at the forefront of the civil engineering sector.